Hello there, PreCalc class. We're back. Sorry it's been a little bit here. So a couple announcements to get going before we get started on 8.1. We are officially in the fourth marking period. So right now, how I've decided to give out class participation is you need to respond to these videos. Reply with literally any comment below so that I know it's you and you're going to get full credit there. It is that easy, that quick. So I repeat, just reply somehow to this video to show me that you're even looking at it, even seeing it. And that's going to continue for the rest of these videos that I'll put out for this time. If by May we don't know that we're going back to school, if we don't know that we're going back to school, that's where I'm going to start asking you to send me pictures of all the work that you've done. So all the Chapter 7 stuff, Chapter 8 stuff, that's where I'm going to be looking for all of that. And those pictures I want emailed to me at jjohnson4@syracusecityschooldistrict.us. So yet again, I need you to reply to this and future videos that are meant for your class. So you don't have to respond to the calculus class ones, but you do have to respond to the pre-calc ones. Clear? Okay. Let's get started with 8.1. Still kind of ties in with the last section that we were doing, but it's kind of a new twist on how we're doing things. It makes writing them a little bit easier. So we're going to define a matrix here. Specifically, we call matrices M by N, and they look like this kind of grid, and they're usually filled up with numbers. You may be looking at this and saying, like, what? A11, A12, A13, a bunch of dots, A1N, and it's going the opposite here, except we go A11, A21, AM1. So what these different indices, they're called, stand for. The first indice here stands for what column you're in. So that first one here would mean we're in, row 1, column 1. And then the second indice here would be what column you're in, right? So we call these M by N, it's just rows by columns. And we can denote these in generic form as Aij, for kind of the indices of rows and columns. Okay, hopefully not too confusing, not super important right now, but just to know rows and columns is important. So let's talk about orders of different matrices. So this first one, just a number 2. It doesn't look like a matrix, except it has these brackets around it, which indicates it is in fact a matrix. And this would just be a 1 by 1 matrix. Okay, next one. We have 1 row and 4 columns. So this would be a 1 by 4. This one is a square matrix because it's the same number of rows and columns, 2 by 2. I guess we could have said the first one was a square matrix as well. And then the last one here, we have 3 going down, 2 going over. So 3 by 2, because 3 rows, 2 columns, just to get you the size of these things. Let's actually see how we can use these, what's going on. Only a couple typos here at the start. So what we were looking at last week is we had a system of equations here, and we want to convert these into kind of what would be a matrix. So all it is you have to bracket these in, and it's just the coefficients we have in front. We have 1x, we have a negative 1x, 2x, 2y, 3y, negative 5y, 3z, there's nothing here, so that is a 0, 5, and now we equal something. The equal sign we kind of denote with a dotted vertical line, and then the same numbers here, 9, negative 4, 17. So one perk here is that we don't have to write out all the x's, y's, and z's. It's just kind of known, excuse me, if you're in the first column here, that's the x variable. The next one, y, z, and then once we hit that dotted vertical line that we're in, kind of what they equal over here. So we're going to now use something that's called a Gaussian elimination, invented by Gauss, as you might guess. And there's only 3 ways that we can go through this elimination, and we kind of did this last week. You can interchange rows. You can multiply by a non-zero constant only to a row. So that's for a row. You can't multiply columns. And then you can add multiples of a row to another row. So let's stick with this example we have here and see how we kind of want to change things. So the row that maybe we want to change here is we want to change row 2. And we like this 0, or the 1 that's here. And we want to use that 1 kind of to eliminate the ones below it. This is Gauss's method. So taking this 1, we could add it to this one. So we want to change row 2. So we can add row 1 to it. So thinking from last week, we rewrite that first row. And the next one, if we're adding these, 1 plus -1, 0. 2 plus 3, 5. 3 plus 0 is 3. 9 minus 4 here is 5. But we also want to change this bottom row as well. So in order to do that, we want to change the third row. And then we want to subtract 2 of the first one. So that's how I'm going to write this. So 2 minus 2 is going to get us 0, which is what we wanted. -5 minus 4, -9. What do we have next? 5 minus 6 gets us 1, and 17 minus 18 gets us -1. Did I do something wrong here? I think I wrote the whole thing wrong initially, but that's okay. We're going to keep going on. Is this okay? Did I botch this already? What's the first one? Oh, that's a negative sign. That's good. Sorry, this was supposed to be negative. So then when we're subtracting 2 here, sorry. This is going to be a -1. My fault. One little negative does throw everything out of whack here. And that will change this 5 as well. That 5 becomes a 1. Sorry, guys. So that was a -2 all along. That -2, when we multiply or add, is going to change things up. Okay. I think we have the correct thing now. Good. Caught it early on anyway. Okay, so we have this 1 here. And notice there's all zeros below it. And everything below it's a 0. That's good. That's what we like. Next thing we're going to look at here is we're going to go down and diagonal. And we want that term to be a 1. Thankfully for us, it already is. And we can use that as an advantage to eliminate the ones below it. So that means when I'm changing here, my matrix, the first 2 rows I actually like. Those are good. This is the one we want altered. So we want to change row 3. And specifically, we want to add row 2 to it. Because that's a positive 1, that's a -1. Keep in mind through my mistakes already. So we just add these together. 0 plus 0, 0. 1, -1 is 0. 3 plus 1 gets us 4. And 5 minus 1 gets us 4. Did I make a mistake again? Man, this is not a good opening video here for the day. Was this supposed to be a -1 and I cannot do things very good? Yeah, this was supposed to be a -1. Row 3. Man, you're getting to see all the mistakes come out here. So then when we add these, this is 2. My bad, guys. So I guess this is the warning that a lot of little mistakes can happen with going through any of this, but this could have happened the other way. I'm going to try to get a little bit more focused here. And the very last thing we want, notice we're good here. 1 and 0's below it. We have a 1 here, 0's below it. That means we would like a 1 in this next kind of diagonal spot, that 2. How to make that 2 into a 1 is we can do half of row 3. So that means the first 2 are staying the same. We get to this point, and here you can really think of this as we have that z equals 2. We know from this kind of bottom statement here. Z equals 2. These are the same exact statement. If z equals 2, we can use now backward substitution to get us everything else we want. So here I would have y plus 3 times 2, because that's 3z equals 5. So y equals -1 here. And then we can do backward sub once more. And I'll put this one over here. X minus 2 times -1 plus 3 times 2 equals 9. X plus 2 plus 6 equals 9. X equals 1. So we have our answer as x equals 1, y equals -1, z equals 2. And this method will prove to be a lot easier and nicer. It's also nicer when I don't make a mistake. Okay, let's look at a bigger one and see how we can use this to get us in row echelon. Ooh, I didn't say that here. That's what I wanted to. So notice once we got here, we have 1s in diagonals and 0's below it. So we have all the 1s on these diagonals going down, and then 0's here. This is defined as row echelon form. Once we have something in row echelon form, solving it becomes real nice, real easy. Okay, so we want to work this matrix and get it into row echelon form. And then we're going to be good to go. Sound good? And this is a bigger one. So our first move is going to be, let's just rewrite this into a matrix. 0, 1, 2, 1, 1, 2, 4, -4, 1, -1, 1, -7, -2, 0, -3, -1, and -3, 2, -2, -19. Quick check to make sure I didn't botch this again. I think I did things okay. Yep, looking good. Great. Okay. Remember, the first thing we wanted is we want a 1 in this top spot. Since we don't have that here, we can do a little interchange right away. So you can just say row 1 flip-flop with row 2, and that can be our donation, or way to denote this is the double arrow. So that was the row 2, and I moved it up, and then row 1 I'm going to move down here. So notice we have the 1 where we want it. We have a 0 here, but we want both of these others below it to be 0's as well. So we want to make that 2 into a 0, make that 1 into a 0. So the best way to do this, we want to change row 3 here. So since I want to change row 3 minus 2 times row 1. Since I like the first two rows, I can keep those the same. Subtracting 2 here. Subtracting 4 there. 1 minus plus 2, really. So this is a 3. Still have a negative 3 here. And then this one is negative 2 minus, 6. Great. Let's do the same thing here. We want to change row 4. So row 4, and let's subtract row 1. 1 minus 1 is 0. Negative 4 minus 2 is negative 6. That's like a plus 1. Negative 1. Negative 21. Let's double check. Make sure I haven't made a mistake yet. Okay, things are looking good. Notice we have this 1 here, and everything below it is 0. That's a good start. Now, we would like a 1 to be here. We got it. We would like zeros below it. We have a 0 there. Oop, not quite a 0 there. So we have to make an adjustment. We want to change row 4. And what we're going to need to do to that is add 6 1s here, right? So 6 times row 1, or we're not in row 1 anymore, sorry, row 2. We're done with row 1, row 2. So we like our row 1 and row 2. Row 3 was okay for now. But this is the one we want to switch. So we have zeros here already. That's good. This is where we said we were going to get a 0. That's why we did that. We're going to have another 0 here. That's good. 6 times row 2. That's negative 12. And a minus 1. So we get a negative 13 here. And then we're left with negative 21 and 6 of them here, 39. Okay, slowly getting into form. Notice these zeros are starting to stack up here. That's exactly what we want. 1s on the diagonals are getting there. Ooh, this is not quite a 1 though. So now we need to transform that 3 into a 1. We need 1/3 of row 3. So keep the first 2 rows the same. Dividing by 3, 1, negative 1, negative 2. And we didn't touch the last row yet. And then finally, we have 1s on the diagonals and 0s below it. This is good. However, this negative 13 isn't quite what we want, so we want to take negative 1/13 of row 4. And if some of you are saying, well, why didn't you just do that before? You're having to write all this out again. You could have done that. We could have, in fact, done 2 steps in one. I'm just taking my time and doing one at a time, trying to not make mistakes as I'm making mistakes. So dividing by negative 13, we have a 1 here, and that gives us a 3 here. So at this point, we have our x, y, z, and remember that fourth one is w. We are officially in row echelon form because we have 1s in the diagonals and 0s here. So this is our row echelon form. That's good. And we can solve this if we'd like. W is 3, and you can kind of go backwards and find all of them. I'm not going to go through all that because this video is already getting a little lengthy. Z ends up being 1, y is 2, and x is -1 if you wanted to go through and check it yourself. Okay, a little bit smaller of a matrix here is this one, and we're going to use the Gauss-Jordan elimination. So somehow I got my name in there just to piggyback off of Gauss, I guess. This is actually what its name is, though. I'm not making that up. Just kind of weird. Okay, 1, -2, 3, 9, -1, -3, 0, -5, 5. Isn't it great just listen to me read off numbers here? Okay. So I'm going to get us to, is this one we just did? Did I plan this out smartly? Yes, I did. So this is one we did back here, except it's actually written correctly the first time. Good job by me. So eventually, after doing a whole bunch of different adjustments, we would be getting to the row echelon form that follows here. And then we went through and backwards subbed everything in, but we want to take it a little bit farther and add in like the Jordan part of this, which actually will bring us to the part we want eventually. Now we're kind of going to go backwards. We start at the bottom and we want to eliminate the things up above it. So since I have this 1 here, I can use that to kind of attack these 2 numbers above it. So I want to change row 2 by subtracting 3 of row 3. So I'm going to start off by writing the bottom one here. And subtracting 3 of them, 0 minus 0, 0 or 1 minus 0 is 1. 3 minus 3 is 0. And then we have 5 minus 6 here, which gets us to -1. Which I think is what we got before. Yep. And then we can go up one more step because I want to change this 3 as well. So I'm doing the same thing. I want row 1, and I'm going to subtract 3 of row 3 again. Notice we have these zeros here, so they don't affect anything. So the x and y parts stay the same. We're subtracting 3 from here. And then 9 minus 6 gets us 3 here. We okay with that? So the next thing we're looking at is this one, and I want there to be zeros up there. Notice how good that is. The 1 here, all the zeros are there. So if we're going to do this, what am I going to need here? So I know these 2 rows are staying the same. So I'm changing my row 1, and I'm going to be adding 2 row 2s to it. So this gets us a 1 here, a 0 here, a 0 here. This becomes a 1, right? 3 minus 2. And so this is called row reduced echelon form, because we have 1s in the diagonal and then zeros everywhere else. And this makes getting our answer completely kind of almost trivial at this point. Since we have an x is 0, 0, x is 1. No x's, a y, no z's, y is -1, and z is 2. So going through this, it kind of gets that answer without having to do the backward substitution. You may be saying, well, why would I ever do that? There are certain instances where this is a lot nicer than others. And there are things in the future where getting it in row reduced echelon form makes life a lot easier. Okay, 2 more examples. It shouldn't take me more than 2 minutes here, hopefully. So we can get systems that have no solutions here. So specifically, this system here has no solutions. And the way you can identify that is this row right here gives us the statement that 0 equals -2, which we know is a contradiction. That is not true. What you may be noticing in a bigger picture is if you look at this matrix over here, the size doesn't quite match what we want it to. Notice we have specifically, if you're looking in here, 3 columns and 4 rows. This is a non-square matrix, a 3 by 4, so we know there's going to be some issues here. And you may be saying, well, let's go back and look at other things. Look at the one we just did. The size of it before the equals side, 3 and 3. That's considered a square matrix, so that we can actually solve this successfully. And if you look at that even bigger one we did before, 4 by 4. This is going back to that old adage of you need the same number of variables as unknowns as equations. If you don't have that, we're going to have something weird happen. Here, you should be noticing this is kind of a smaller one. 3 and 2 though. So when we get here, there's in fact going to be an infinite number of solutions, and this is going to be set up kind of like we did in the past, where it's like x plus 5z equals 2, and then we have y minus 3z equals -7, and you can go through and say, well, if z is a, then we're going to have y equals -7 plus 3a. You can kind of go through and do that whole process, x equals 2 minus 5a, and these would be our set of infinite solutions. The big takeaway is if they're of different sizes, you know something weird will happen. Okay, homework here that I'd written on the board, and big thing, leave a comment. This is now class participation. Tell someone, text your friends. I don't have to go through and email and personally phone call everyone. I know a lot of us are doing this. Leave a comment. Quick, it could be as quick as I got it, saw it, yep. Okay, stay safe, guys. I'll talk to you soon. Bye.